Hello. Today we're going to look at how to find lengths in non-right angle triangles by using the sine rule method. The sine rule is A over sine A equals B over sine B equals C over sine C. And you'll see here you've got lowercase and uppercase. The lowercase, the little a, little b and little c, are lengths, and the capital A, capital B and capital C are the angles. Now there is a method where you can switch the A over sine A around so it becomes sine A over A, but me personally, I like to learn only one fraction and then manipulate it using solving equations. Okay, but it is a personal preference. So the first thing is, in order to find lengths using the sine rule, what we need is we need two angles and one of the opposite lengths of one of these angles of the triangle to find an angle using sine rule. To find a length, using sine rule. Okay, so basically today I'm going to be doing everything in degrees, so if you could set your calculator to degree setting, and basically we're going to go through how to work out the length using sine rule. Okay, so first of all I'm going to show you how to label the triangle. And how we label the triangle is we choose any vertex for A, B and C. So what I'm going to do is I'm going to choose this side here as A, this one up there as B, and this one there as C. So the length opposite the vertex is the lowercase equivalent. So if this vertex here is capital A, then we go to the opposite length, and that is little a. Similarly, this vertex here is B, so when we move across here, this side here is little b. This one, vertex, is C, so we move across, so this side here is little c. Okay, so we label the triangle just like that, and then we write down the sine rule formula, which is A over sine A equals B over sine B equals C over sine C. Then we substitute our knowns from the triangle into the formula, and then we solve with change side, change sign. If you're not sure what change side, change sign is, then please watch our solving equations video. If that doesn't answer, then just click on the link on our website on the description to the video and ask us. Okay, and we'll explain. Okay, so let's move on to an example of sine rule working out the length. So what we've got here is, so I'm going to label the triangle first. So I'm going to call this vertex here B. So therefore the side or the length or the side opposite big B is little b. And then I'm going to call this vertex A. So therefore the length opposite vertex A is little a. This one here is capital C and little c. So therefore what now we've got is we've got vertex A. So I'll just write it here. B equals, and then little a equals, and little b equals. Okay, so let's have a look. So little a equals 14.5. Big B equals 36 degrees. So A equals 112. And little b equals x. So basically what we're trying to do is we're trying to find out what x equals. Now the c's, we don't know the angle here, this one, and we don't know the length here, and we're not trying to work out either of those two at the moment. So basically we just ignore that third fraction. In the sine rule we only use two fractions. Okay, so now we look at this fraction here, and we've got one fraction equals another fraction. Now the best way really of doing it is something called cross multiplication. Yeah, and basically what you do here is you move this sine of 36 up there, so a divide by sine of 36 on this side becomes a times sine 36 when you move it across the equal sign and up, and the other one is you divide by sine of 112 on this side, so when you move that up there across the equal sign it becomes times sine of 112. Okay, so that is what's called cross multiplication. Okay, so a divide on one side becomes a times on the other, and a divide on this side when you move it across the equal sign becomes a times on this side. So now what we've got is we've got our unknown, and our unknown in this case is this x here, and that's x times sine of 112. So what we've got to do is to try and get this x by itself. Now sine of 112 is a known, because if you put that into your calculator you get a number. So what we do is we circle that, and then we move that across to the other side. So a times by sine of 112 on the right hand side becomes a divide by sine of 112, and that is change side, change sign. Okay, so a times by sine of 112 on this side, when we move it over the equal sign to the other side it becomes a divide by sine of 112. And then you can quite clearly see we've got x's which are our unknowns on one side, and then we've got all of our knowns on the other. And if we put this into our calculator we get 9.19 centimeters to 2 decimal places. Okay, so it's now your turn to have a go, and these are our two questions that I would like you to have a go at. Quite good questions. Question 2, there is a bit of a trick to it at the beginning, so just be careful with that. Remember to copy out the questions. Step 1 is label A, capital A, little a, etc. Step 2 is general formula. Step 3 is substitute and solve. Okay, so basically copy out the question and have a go, and then in a couple of minutes I'll be back again to answer the question. Okay, so pause and have a go. Okay, so what we're going to do is I'm going to label question 1 first. So I hope that you've had a good go at the two questions. What I'm going to do is I'm going to label this vertex here A, this one here B, and this one up here C. Now you can label it in a different format. If you labelled that one B, A and C, it doesn't matter. Okay, so this angle here is vertex A, this angle here is angle B, and this side here, that one there's little a because it's opposite the capital A, and x, the x length or x side, is opposite capital B, which is little b. Okay, so now what we've got to do, and of course this side here is little c. So A equals 16, B equals 74, etc. Okay, so let's get on with the answer. So first of all we've labelled, and then what we've got to do is we've got to write down what the A equals, B equals, etc. So A, B, capital A and capital B. So little a is 16, little b is x, capital A is 58 degrees, and capital B is 74 degrees. So now, and that's from the triangle, these. So now what we've got to do is to substitute these into our sine rule general formula. So little a is 16, capital A is 58, and remember, a lot of pupils forget the sign in the sine rule. You've got to keep those in because it is the sine rule, and it is a trigonometric identity that is required for the trigonometric ratio to work. Okay, so little b is x and capital B is 74. Now C, we're not interested in that fraction because we're not trying to work either of them out, and also we're not given any information regarding it, so we just ignore that, and for the sine rule we only use two fractions. So the first step is to try and get rid of these fractions, and we circle the sine of 74 and we bring that up there. We use a method called cross multiplication when one fraction equals another. So a divide by sine of 74 on the right hand side. When we move a divide across to the other side, it becomes a times by sine of 64. Times by sine of 74, sorry. Next one, we're dividing by sine of 58 on this side, so when we bring that across from the left hand side of the equal sign to the right hand side of the equal sign, it changes from a divide sine of 58 to a times by sine of 58. Okay, so now you can see that we've got rid of those fractions by a method called cross multiplication. Now we're trying to get our x, which is this, by itself. Now sine of 58 is a number, so if we're timesing by sine of 58, when we move that across to the other side, it becomes divided by sine of 58. And you can see that on the next step. 16 times 70 for sine 74 divided by sine of 58. And then quite simply we write that into our calculators to get 18.14 centimetres to 2 decimal places. Okay, so well done if you managed to get that one correct. And let's go through question 2. So question 2, and let's label our triangle first. Okay, so what we've got here is we've got 72, 40, and you'll notice that the x isn't opposite one of these angles, which it has been previously. See, the x is like opposite the 74 degrees. So what we've got to do is we've got to work out what this angle here is first. So the three angles in a triangle, one, which is the 40, and then the 72, and so these two angles here. If we add both of those up, so what it would become is 40 plus 72, and 40 plus 72 is 112. Okay, so therefore the three angles in a triangle have got to add up to the same as angles on a straight line, because if you were to cut out the three angles and place them together, they would equal 180 degrees. So therefore the angles in a triangle equals 180, so you've got to take away 112 from that and you get 68. So this angle here would be 68, and you can now see that you've got an angle opposite the x. So what I'm going to do is I'm going to call this one B, this one A, because I've called this one A because I've got the angle and the length. this one here C, and this one here little c. Okay, so let's go back to our answers. So yeah, and that's just explaining, work out the angle opposite the x, which is what I've just done, the 68 degrees, and then basically we've got our formula now. And I'll just enter in this c as well, because I think that we do have some information about the c. So the angle c is 72 degrees. Okay, so I'll just put 72 in there. Now it's okay. Now, but you can still see that, you know, in these first two fractions here, 6.4 and 40, what you're after in the sine rule is a complete fraction with no unknowns in. And the c, we don't know anything about that c, the length of c. So again, c we get rid of. Okay, so we've got our equation, and there's potentially four unknowns: a, little b, capital A and capital B. And what you're after is two fractions where you've got three knowns. So in this case the three knowns are 6.4, 40 and 68. Okay, and then you've got one unknown. So the first thing that we've got to do is to get rid of the fraction, and we get rid of the fraction by cross multiply. Okay, so basically we divide by sine of 68 on this side, so when we bring it over to the other side of the equal sign, it becomes times sine of 68. Next one, we circle the sine of 40 and bring it over, and you can see the cross quite clearly here, and that becomes divided by sine of 40 on this side, on the left hand side. When we bring it over, it becomes times sine of 40, so it becomes x times sine of 40. Okay, so now we've eliminated the fraction and we've got all of our things on one line. So now we're trying to get our unknown by itself, and our unknown is this x here, and it's x times sine of 40. So 6.4 times 6.8 is on this side, so what we've got to do is to bring over the other known, because if you were to put sine of 40 into our calculator, you would get a number. So sine of 40, we bring it over to the other side, and if it's times on this side, it becomes a divide when we move it over. Change side, change sign. So therefore, new line, it becomes 6.4 times sine of 68 divided by sine of 40. And then if we put that into the calculator, you get 9.23. So very well done if you got those two right, especially if you got question 2 right. Okay, so that's our lesson today on finding a length of a non-right angle triangle using trigonometry sine rule. Just a quick reminder, sine rule is little a over sine big A equals little b over sine big B equals little c over sine big C. If you have any questions, then please click on the link in the description and we are happy to help.